All right, practice problem 713. This is a more complicated circuit, and we're going to look at what's going on here. Circuit, switch S1. S1 in the circuit is closed at time equals 0. So at time equals 0, this is closed, and switch 2 is closed at time equals 2 seconds. So these two switches are both starting off open. So what is going on? And they want us to find the current as a function of time for all t, and then find the current 1 and current 3. Well, and the current here is over here, right? So I of t. They want us to find the current basically into the inductor. I mean, if everything's open initially, right, you basically have no current flowing through this loop, right? The current would just be passing around like this through the 15 ohm resistor. So when both of these are open, this is not really interesting. This is just 0. It starts to get interesting when you close this. This is still open, right? So now you have current flowing. Well, it's flowing, I guess, through both of these, right? It's got this loop with a 15 ohm resistor, and it's got a 10 and a 20 ohm resistor. So the current's going to split between these two nodes. And we're going to find, so we're going to have a certain current that it's going to go towards, right? If you were to leave this closed and this open for infinite time, right, you would get a certain current passing through the inductor, right? But then at 2 seconds, you close this switch as well. So this switch stays closed, and now you've basically shorted out the 20 ohm resistor. So you have current that's splitting here, and now when you close this at 2 seconds, you basically introduce a short. So all right, this time I noticed my microphone quit on me. I don't know when, but yeah, you're going to short this out. So you're eliminating the 20 ohm resistor from the circuit by turning on this switch. So let's look at this. Let's look at this problem on the document camera. I'm going to turn off the PowerPoint. Okay, so here we are. You can draw this stuff out. I've reminded ourselves what the RL current with time equation looks like, right? And what are we doing here? Well, all I did is I redrew this with S1 closed. So this is what the circuit looks like when you have S1 closed. You have a 12 amp source, 15 ohm resistor, and two resistors in series here, and you have the current. So the first thing I'm going to do here is, I guess I'm going to do a source transformation. All right, so that's what it's going to look like. We don't know the voltage yet, right? V equals IR. So we have a 12 amp source and a 15 ohm resistor. This is going to give us 180 volts. So this is our voltage source. And this is our transform circuit. So all I did was a source transformation. Let me circle and put source transformation. I'm just going to write trans. So the source transformation. What else? Well, okay, so now with this source transformation, right, this is our current is still going on over here, I, right? I at time 0 equals, I guess this is technically time less than 0, right? So I naught, right? This is your initial current. So let me put a little minus up here. So this is, what is the current initially? Well, let's see. Initially, the current is 0, but then at time t, what is t going to be? T is going to be greater than 2, less than, oh, sorry, greater than 0, less than 2. Right? So now we have time greater than 0. So now we've got I 0. Well, we don't even need this. Now we're looking at I infinity, right? Which is just I steady state. So what is this after a very long time? Well, assuming we don't do anything else to this, right? After a very long time, this current is going to steady out to be 180 volts over the sum of these resistors, right? 15 plus 10 plus 20 ohms. And that's just going to be, what do I have here? 4 amps. So 180 volts over 45 ohms. That's your infinite time. Again, this is for between 0 and 2 seconds. So we haven't shorted this out yet. And so we have an equation here. Oh, wait, we have to do tau. What is tau? Tau equals L over R. And that's just going to be the 5 Henry over 45 ohms. So tau is equal to 1/9, right? And this is seconds. So we have an equation now. Oh, I don't know why I keep writing E. I of t equals, we've got 4 minus, remember I naught is 0, so we just have a -4 up there. 4 minus 4 e to the minus 9t. This can just be rewritten, this is amps, right? This can be rewritten as 4 times 1 minus e to the minus 9t amps. And this is for time between 0 and 2 seconds. This is your initial time. Oh, all right. That's your initial time. What else is happening when S2 is closed at t equals 2, 20 ohm resistor is short-circuited. Short-circuited. But I 2 minus equals, oh sorry, 2 plus equals I of 2 minus. So this is saying that at 2 seconds you bypass that resistor. However, the instantaneous current just before and after you actuate that switch is the same, right? So this is equal to, it's equal to time here equals to 2 seconds. So I'm going to write this equation. I'm going to have 4 times 1 minus e to the minus 18, right? So 2 seconds times 9 constant is minus 18. This equals, it's approximately equal to 4, right? But if you look at it in your calculator, you're going to get 3.9. I think you have 7 nines here. 1, 2, 3, yep, 4, 5, 6, 7, before you hit another number. So you can see this is approximately equal to 4. So in 2 seconds, it's pretty much reached the infinity, or the steady state current that we predicted up here, the 4 amps. So we're going to use that for our initial resistance. So I naught, and this is for t greater than 2 seconds, I naught equals 4 amps. So that's the initial current. 20 ohm resistor, 20 ohm resistor. is out, right? Out of the analysis. I'm not even going to I'm not going to draw the circuit. This is just, if you want to redraw the circuit, you can redraw it as just this without the 20 ohms. So, well, it's going to have a line in place of that. So the 20 ohm resistor is shorted. So the current, the steady state current I sub S is going to equal 180 volts divided by, we've got 15 plus 10 ohms. So that is 7.2 amps. And then the Thevenin resistance is just 25 ohms. So our new time constant is 5 over 25. Right? So this is just, again, the Thevenin resistance is the total resistance of the circuit. It's 25 ohms. This is just 1/5 second. So I sub t, or I of t, is just going to equal 7.2 plus, now this time we have an initial current, 4 amps. We've also got the steady current, 7.2, e to the minus 1/5. 1 over 1/5 is 5. So we got to be careful here. This is t minus 2. This is for all t greater than 2. So for this particular function, right, if time is 2 seconds, right, 2 seconds, this becomes 0, right, e to the 0 is 1. Then you have 7.2 plus 4 minus 7.2. This gives you 4, right? So that's I of 2 seconds is 4. That's our initial current, 4 amps. So just you can double check things by plugging these numbers in as you go, right? Your current at time 2 seconds should be 4 amps. So this is going to be a continuous function between 2 seconds and then infinity, right? So when you can see, right, as time goes to infinity, this is going to get very small, and you're going to go to the steady current of 7.2 amps, right? This becomes basically 0. So now we have this equals 7.2 plus, I guess it's minus, minus 3.2 e to the minus 5 t minus 2. So you can write this as I of t equals, we've got 0 for time less than 0. We've got 4 times 1 minus e to the minus 9t. And this is amps. This is for 0 less than t, less than 2. And then we have 7.2 minus 3.2 e to the minus 5t minus 2. And this is amps again. This is for t greater than 2 seconds. And then I ran out of room here. So let's just look at, we needed to find I1 and I3. So what are those currents? Well, for I1, right, we're going to use the equation for time between 0 and 2. So that's going to be 4 times 1 minus e to the minus 9th. This actually equals, what does it equal? Oh, this gives you a little less, well, it gets you a little less close to 4 than before. So we've got 3 9s and a 5, right? 3.9995, which is basically equal to 4 amps. I of 3 seconds, right? So the current at 3 seconds is going to be a little more interesting, I hope. 7.2 minus 3.2 e to the minus fifth, right? So be careful, right? 3 minus 2 is 1, so that's where we get the minus fifth from. And this is going to equal, I should move this up, 7.178 amps. So those are your two, these are your equations up here, right? This is I of t for all time, right? We have different regimes. And then this is the current at 1 second and the current at 3 seconds. So this concludes Chapter 7, and thanks for watching.